66 million years ago, on what the evidence now tells us was a spring morning, a hadrosaur waded through a shallow river in what would one day be North Dakota. The Cretaceous world, 165 million years in the making, was exactly as it had always been. Then, above the Gulf of Mexico, a light appeared, brighter than the sun, and the ordinary morning ended forever. The late Cretaceous was not a world on its way out. Tyrannosaurus rex patrolled the northern plains, Triceratops grazed in herds, pterosaurs crossed open skies, mosasaurs ruled the seas. Dinosaurs had dominated this planet for over 150 million years, nearly 20 times longer than modern humans have existed. Whatever ended that reign did not creep up on the world. It arrived from outside the planet entirely, and it arrived at 72,000 kilometers per hour. The first evidence came not from bones, but from chemistry. In 1980, physicist Luis Alvarez and his geologist son Walter published a finding that shook the scientific establishment. At a limestone cliff in Gubbio, Italy, they had found a razor-thin band of clay, barely a centimeter thick, marking the exact moment the Cretaceous ended. That clay was saturated with iridium. Iridium is extraordinarily rare in Earth's crust, but it is abundant in asteroids. The Alvarezes had found the Impactor's fingerprint pressed into stone. That same iridium anomaly has since been confirmed at over 350 sites worldwide. The signal is unmistakable, but where was the crater? The answer had actually been found in 1978 by a geophysicist named Glenn Penfield, working for Pemex, Mexico's national oil company. Penfield had spotted an enormous circular structure buried beneath the Yucatan Peninsula in confidential exploration data. Company rules kept him silent. 13 years passed. It was not until 1991 that Alan Hildebrand formally identified the structure, the Chicxulub impact crater, 180 kilometers across, buried under more than a kilometer of sediment. The smoking gun had been sitting in a corporate filing cabinet the entire time. The impactor itself was between 10 and 15 kilometers wide, larger than Mount Everest is tall. It struck at roughly 20 kilometers per second, 72,000 kilometers per hour, when it hit the atmosphere. The energy released, approximately 100 teratons of TNT, about 1 billion times the bomb dropped on Hiroshima. To match that output, you would need to detonate a Hiroshima bomb every single second, without stopping, for 31 consecutive years. The scale is almost impossible to hold in the mind. Almost. And it hit the worst possible place. Not the deep ocean, not bare granite. By pure geological chance, the impactor struck the shallow carbonate shelf of the Yucatan. Rock laced with anhydrite, calcium sulfate. The impact vaporized an estimated 100 billion tons of sulfur, blasting it directly into the stratosphere. A 2020 study confirmed the impactor struck at roughly 60 degrees from the southeast, essentially the worst-case angle for maximizing climate-damaging gases sent aloft. Had it hit the deep Pacific, far more species might have survived. It did not. The universe managed to find the most catastrophic rock on Earth. In the first second after contact, rock vaporized. A hypersonic fireball expanded outward at speeds no force on the surface of this planet had ever produced. The crater, 20 kilometers deep at its peak, fully formed in roughly 90 seconds. At the center, rebounding rock briefly built a mountain taller than the Himalayas, then immediately collapsed, leaving the circular peak ring that drill cores recovered in 2016. All of that happened in less time than it takes to brew a cup of coffee. Simultaneously, a magnitude 11 earthquake radiated outward through the crust, far beyond anything in recorded human history. Its seismic waves reached the opposite side of the planet within 20 to 30 minutes, 3,000 kilometers north in what is now North Dakota. An inland river system was about to preserve the most intimate record of this day ever found. An earthquake-triggered surge, a seismic seaching wave, swept through within hours of impact, entombing fish, trees, and large animals in a single catastrophic deposit. When paleontologist Robert De Palma excavated the site, called Tanis, he found fossilized fish with impact tektites, glass spherules from the asteroid, still lodged in their gills. These animals had been alive and breathing during the debris fall. They inhaled the asteroid. Then, in 2022, a study in Nature analyzed the bone growth rings of those fish and found a season. Late boreal spring. Breeding season. Eggs still unhatched. The impact struck at the worst possible time. The fireball, the heat pulse, the earthquake, each one alone a catastrophe beyond modern reckoning. But the final killing mechanism came slower and lasted far longer. 100 billion tons of sulfur aerosols, combined with soot from continent-wide wildfires, rose into the stratosphere and circled the globe. Sunlight failed. Photosynthesis collapsed, in the oceans first, then on land. Every food chain on Earth unraveled from the bottom up. Global temperatures dropped an estimated 15 to 25 degrees Celsius. The darkness may have persisted for 1 to 2 years. The cold, for potentially decades. 75 to 76% of all species on Earth went extinct. The impact did not just kill the dinosaurs, it dismantled the world they lived in. The story carries one more layer of complexity. The Deccan Traps, an enormous volcanic province in what is now India, had been erupting for hundreds of thousands of years before the asteroid struck, flooding the atmosphere with CO2 and stressing ecosystems already. Some researchers argue the Chicxulub impact may have seismically intensified those eruptions within days of the strike. Others suggest volcanism deserves more credit for the extinction than it typically receives. The scientific consensus still holds the asteroid as the decisive blow, but the world that died was not entirely healthy to begin with. Nature rarely offers a single clean cause. Every non-avian dinosaur, every pterosaur, every mosasaur, the plesiosaurs, the ammonites, gone. But this ending is not quite an ending. Birds are, by strict scientific definition, avian dinosaurs, direct descendants of the theropod lineage that survived. Every sparrow, every eagle, every penguin alive today is a dinosaur. 10,000 species of them, filling every ecosystem on Earth. And in the shadows of the Cretaceous, small, warm-blooded mammals had spent 150 million years living in the margins. When the skies finally cleared, they emerged into a world with no large competitors. They diversified. They evolved. Tens of millions of years later, one of their descendants drilled a core into the Yucatan seafloor and found the proof of the day that made us possible. The asteroid did not just end a world, it built ours.